Today we're going to be talking about how to find the domain of a multivariable function. And in this particular problem, we've been given the multivariable function f of xy, or you could also think of this as z, is equal to the natural log of quantity 9 minus x squared minus 9y squared. So this is going to be similar to the process we followed when we were looking for the domain of a single variable function where we just had some function for y in terms of x. Now we have a function for z in terms of x and y, so multivariable. All we're going to be doing is looking for points where this function is undefined. So sometimes you're going to have a multivariable function like a polynomial function that's defined for all real numbers in cubic space. And in that case, your domain, the domain of the function, is going to be, we write it like this, all reals, but we write this cubed to denote that we're talking about three-dimensional space. And that would be for something like a function in terms of x and y, so z in terms of x and y, that's equal to, a typical polynomial function. So let's say x cubed y plus 3x squared y squared plus x plus 1, or something like that, right? We have a function for z in terms of x and y, but it's a polynomial function, so it's defined everywhere. But sometimes you're going to have a multivariable function where the function's going to be undefined, and things that you're looking for commonly are, values inside a natural log, values underneath the square root sign, things like that. We know that the natural log function isn't defined when we have 0 or a negative value inside this natural log, which tells us that for our particular function here, 9 minus x squared minus 9y squared, this value inside the natural log, has to be greater than 0. If you just plug natural log of 0 into your calculator, you're going to get an error. If you plug natural log of a negative number into your calculator, you're going to get an error. And that's because natural log isn't defined when the value inside the natural log here is less than or equal to 0. So we want to keep this value greater than 0. If you had a square root in your multivariable function, you would want to take the value underneath that square root sign and set it greater than or equal to 0 to define the domain, because we can't take the square root of a negative number, or at least when we're talking about the domain, we're not interested in imaginary parts of the domain. We only want the real numbers for which the function is defined. So same goes for here. We want this value to be greater than 0. Now we just need to simplify this a little bit. And what we can do is add x squared and add 9y squared to both sides. We're going to get 9 is greater than x squared plus 9y squared when we add x squared and 9y squared to both sides. If we flip that around so it's a little easier for us to see, we can see x squared plus 9y squared is going to be less than 9. Now what we do is if we divide through by 9, we're going to get x squared over 9 plus y squared is less than 1. And at this point, we should be able to see that we have an inequality which is in the standard form of a wide ellipse, right? The standard form of a wide ellipse is x squared over a squared plus y squared over b squared is equal to 1. And when we have that standard form, our ellipse looks like this. If we have a two-dimensional coordinate system like this, our ellipse looks like this. We'll draw it here in green. So it's a wide ellipse that's centered at the origin like this, and the values that define the ellipse here, so this point right here is going to be x equals a, this point right here is going to be at x equals negative a, this point is going to be at y equals b, and this point right here is going to be at y equals negative b. So in other words, for our ellipse, we can see that a is equal to 3 because this 9 is equal to a squared. We get a squared equals 9, take the square root of both sides, and we see that a is equal to 3. So we know that for our ellipse, this is 3, this is negative 3. And then for b, we have y squared over 1 here. So we're going to get b squared equals 1, or just b equals 1. So we know that this is at 1, and this is at negative 1. So we know that our domain consists of all of the points inside this ellipse. So everywhere inside the boundaries of this ellipse, everywhere we go, all of these coordinate points are defined in the domain of our function, because we said here that the domain has to be less than 1. So everything on the inside, not including this boundary line. So this boundary line that we drew in green here that defines the ellipse is not included in our domain, because we're saying that this value here is less than 1. If we had less than or equal to 1, it would be all the points inside plus the boundary line included. But because it's less than 1, it's just the points inside the ellipse, not including the boundary. So that's how we can sketch a picture of our domain, or all of the points that are in our domain, because this inequality happened to come out cleanly into the standard form of a wide ellipse centered at the origin. So we draw a picture of it, we shade in all of the points on the inside which define the domain of this multivariable function f of x, y, not including the boundary line that we drew in green.